Hey everybody, it's Craig Maynard again, first senior mentor for First Robotics, working out of Calgary, Alberta. And this is our second day, actually our third day of our 3-day build. Today we're going to be looking at some concepts, some brainstorming concepts. So a number of us got together, Max and Peter and a few others got together, and we put out some ideas that we could use for the various components in our robot. And I kind of wanted to talk to you about these. Again, I'm going to bring up my favorite book in the whole world when I'm doing engineering design methods, strategy for product design. And we're going to look at something today called morphological charts. So a morphological chart is a way of evaluating all kinds of ideas that you may have. You can see we've got these sub-functions. We've got lift and sift and separate and all those things. All the sub-functions are on the side. And then we have a number of ideas across the top. And the more ideas you can get, the more ideas you can have for each one of these sub-functions, the more ideas, the better your robot's going to be. You've got more choices to work from. So we're going to build a morphological, we're not going to really do a morphological chart, but we're going to come up with several ideas for each one of the elements of our robot. So the robot itself, when you think about a robot, and I try to do this with my students when I'm teaching them projects, is don't look at the whole animal, look at the parts of it, look at the components that put this, that make the system work together. And really, when we're talking about the mechanical systems in our robot, there are three things that we have to think about. And theoretically, you could consider them as three separate sub-projects. One of them is the end effector. And the end effector is the thing that's going to be grabbing the cargo hatches. It's going to be grabbing the ball. It's going to be holding them. The end effector has to hold them through all the rigmarole as it's getting to where it's going. And it's got to release it at the right time. That's a very important job, and that's the end effector. And the manipulator, that is what moves the end effector. Now, your end effector could be rigid, always in the same spot, or it could be moving up and down or moving in 3 dimensions. It's up to your own design and your requirements. So the end effector is usually hooked onto some kind of a manipulator, which you need to worry about. And the third thing in our case is the mobility system. We need to have some way of getting the robot around the field to do all the things that it has to do. So we've got this mobility system. And those are the 3 mechanical systems that we're going to be looking at in this discussion that we had discussed in our meeting a few earlier on tonight. So I wanted to share some of those ideas with you. So the first thing we looked at was the mobility system. So we said with the mobility or the drive system here, our biggest challenge is to be able to climb up these elevated areas, at the launch area. So if you were to go up to the low one, that's a 6-foot climb, which is actually pretty good. It's a pretty good height. But if you really want to get a lot of points, this 19-inch climb to the top level, level 3, would be the best. Don't forget, if you can get enough points in your by putting yourself up on enough levels, you can get yourself a ranking point, which is really important. So if you can get your robot up to the top of this 19-inch level, there's going to be a lot of people that are going to want to have you on their alliance. So that's the trick. We've got to get this robot here up to there, or this robot up to there. So there was a number of different ways we had brainstormed into actually doing this. I'm just looking for my notes here. Here we go. Now, the simplest way, one way we thought of doing it was just with a simple rod on the bottom of this robot, and that rod would be perhaps a cylinder or a threaded screw or something like that. That would simply lift the robot up, right? Lift the robot up, and hopefully the drive wheels are still engaged in the back here, and this would be a very slippery end that we suggested. And it would just push the robot up and probably suck that drive shaft up and then lift itself onto the top surface. That was one way to get on the low end. Another way that was discussed, was brought up by the group, and it seemed like a really interesting way of doing it too, was to have an L-shaped mechanism. So the L-shaped mechanism was actually pinned right here. It was pinned, and it would rotate around. So as it rotated around, it would hopefully come onto this top part of the platform and physically drag the robot up as it rotates. So basically just a big kind of an L-shaped claw that drags it up, and then hopefully the robot can get itself up the rest of the way. So there was that was another approach. So there's approach number 2. Approach number 3 that we considered was the robot itself perhaps has 2 drive systems. Like there are 2 linear actuators like this. Could be worm screws, could be a pneumatic, could be maybe something pulling it down on the chain or something like that. But basically the robot would lift itself up right there, and we weren't totally sure of how the robot was going to go forward from this point. Perhaps a wheel on here or something, would be a little set of wheels, maybe a little mini car at the bottom that would sort of drive it forward. And then of course this would have to come up, and I guess this too, and then pull itself up the rest of the way. So they thought about doing it that. That's the 3rd approach. So there's 3 ideas to get it up. A 4th idea that we played with to get the robot to the top of the 19-inch was a single angled thrust. So the idea is if we had a shaft like this at an angle, right, as it extends, the robot would be pushed up against this side right here. So it would have to go up, but as soon as it clears that, it would bump forward, right? A bump forward, and then perhaps bump forward more as it pushes up until the wheels are actually there, and then continue on its way. And this would have to come up, I suppose, and drag itself back up. So the idea of having an angled rod that passes through the center of gravity of this robot may actually work as a way of getting it up there too. So there's a 4th idea that we had for ascending this this level right here, and we haven't decided on one yet. We're going to look at the systems and decide which one would work best for us. But we certainly want to get that little robot up there, and it's going to be very hard to get up 6-inch unless of course we had something like this little tracks on my Cosmo here that it can actually pop up. But I don't think you're going to get any tracks that big. You've seen some of the anti-mark systems that have the tank treads, right? That kind of go like this. Now there may be a possibility, if you have those tank treads, that you could get up there with the tank treads 6 inches high. Well, maybe. Who knows? I don't have those tank treads with me anyway, so it's not something I can work with. So there are 4 or 5 ideas for your drive system, which may get you up there. All right, now the end effector was the next part. The end effector has actually 2 things we have to worry about. The end effector has to handle the cargo hatch and has to handle the ball, right? So the cargo hatch, well, that's a really interesting device. There's many ways of grabbing it. Of course, it could be grabbed from the side physically. It could be hooked underneath, and lifted up, and out of its area. But the couple of ways that leapt to mind for us, one way was to have something that goes in the middle of this and expands out. Now it could go when it goes in the middle, it could expand out in 2 directions, like 2 fingers, and as it expands out, it would center itself. So as you could imagine, this CD right here, if I had two little fingers like these, yeah, I'm just making it up as I go, that actually went inside there and then separated like that. They could lift the disc, and if they're pushing hard enough, they will almost center it too. So you could use 2, or you could use 3. You could use it in a triangle shape. I've seen that as well. And your end effector would have to go into the middle of this hole and then expand out in 3 directions. Like this. There's a second way of doing it, and then you got a very good control of this thing. A nice little small manipulator. Another way of doing this, and I've seen this done in industrial systems sometimes, is with a kind of a balloon type device. It's a membrane, a balloon. So if I could imagine a little balloon device with this is the side view, and the disc is going in there. It pops inside the disc, and then it blows up. You inflate it with a little bit of air pressure, and it swells. And as it swells, it locks itself on the disc. And that's a good way of doing it too. So but you have to put a lot of pressure, air pressure, into this thing. I worry that our little reservoirs we have, the little tanks of air, wouldn't have enough air pressure to be able to generate the vacuum. You'd have to have a vacuum extractor, and those tend to use a lot of volume of air to generate a small amount of vacuum. So that's another way of doing it. So there's one way, two way, three way. A fourth way, of course, is to grab it from the outside. Another way we talked about was if you have suction cups. If you have a small suction cups, like this is a big one, but if you had little tiny suction cups and you could grab the surface on this disc anywhere you want and apply the suction and put it on. Again, you'll need a vacuum extractor, and those might not be great unless you have huge tanks to work with. So suction cups could work. And the fourth way, we had one more way, and that is to grab a hold of the Velcro, right? So I've seen some designs where they have a plate that has Velcro on it, like this. And let's just put it on a triangular surface like that, and they push the plate against the disc, and that sticks. And then when it pulls away and mounts it on the cargo or the rocket, the cargo vehicle or the rocket, it has to use perhaps 3 little pistons right here, I don't know, that push it out, that actually have to separate it. So this little disc would have to be, the cargo plate would have to be pushed away from these little bits of Velcro in order to get them to work. So there's a fourth way of doing it, and that obviously could work. I've seen it working really good in some robot in 3 days. Another way that we were thinking of that we haven't seen done yet is an idea where you have two wheels like this, right? And this is a side view of the disc. You have 2 wheels like this, and the wheels are sitting on top of a I'll draw one there, and I'll draw one there, and they have Velcro on the outside. Of course, the opposite Velcro to the one that's on the cargo hatch. So what we would have is these things separated like this, and perhaps a spring mechanism, right? So this is on a slot with a spring mechanism, and when you can pick it up obviously by sticking to it, but when you want to release it, you pull the wheels inwards, and the wheels actually would roll off the Velcro, right? So they would actually roll off, and I find that rolling off Velcro works really good. It would roll from the Velcro side to the flat side, and that would work really well. So there's an idea. They could be brought in using electrical methods. Maybe the motors could be attached to the wheels and could drive it in, or it could be a pneumatic piston, pneumatic cylinder that draws it in like that. So there's another way. So there's about 1, 2, 3, 4, 5, 6 or 7 ways of getting control of that cargo hatch. It's important you do get control of your device. That's the whole function of an end effector. So there's the cargo hatch. Now, the other thing we have to worry about is the ball, okay? And the ball itself, as you can see right here, she's a beauty. It's a great big one. You look at the characteristics of it, it's got a very rough surface. Might not be good for vacuum because of its sort of rough surface. And when it's fully inflated, I believe it has to be 13 inches in diameter. I'm not sure. Make sure you inflate it to the correct diameter, because you can underinflate this thing and it's not legal size. So you want to make sure it's going to be the right size for the FIRST Robotics competition. Because if you're all set up for a ball that big and the real balls are that big, your robot might not do so well. So the ball, number of ways we thought of getting the ball. The simplest way for getting the ball, we thought would be perhaps a little fork method, where we have, here we go, that's good. Cargo ball, can you see that? There we go. So maybe just a little fork method like this, where we have a fork, and it pivots at this particular point. It pivots at this point, so it would go down on the lower part of the ball and then tilt itself up to get control of it. and when it wants to release the ball, tilt itself down. So that's very simple. Get underneath it and lift it up and tilt it in. I've seen, obviously the other ways would be including some wheels on there. So if you had a similar kind of a fork mechanism, but drive wheels like this, right? Perhaps some nice sticky wheels like these ones on the top and the bottom, you could grab the ball like this, and you can pull it in with the wheels, or you could push it out with the wheels too. And that may give you a little bit of a pop too. And hopefully, you'll have this thing pivoting so you can angle it as well. So the ball itself could be picked up from the ground and angled up and maybe popped up into one of the vehicles, right? Popped into the rocket ship or popped into the cargo vehicle. All right, so there is another way. Another way we thought about maybe capturing the ball. Of course, I'm going to bring back the suction cup again because I don't know whether you can find one that's going to work or not. But if you had a little suction cup like this guy right here, a little suction cup that you could glom on the side of your ball, you got great control of it as long as you can keep that suction going. And a very, very light, simple technique. But again, it's getting that super efficient vacuum extractor so that suction cup would work. That's the trick, and I don't know. I'm not too confident that would work very well with our little reservoirs, as I said. A fourth idea was if this is a ball, again, draw the ball like this. Perhaps we could have a box. This is an outline of some kind of a rectangular structure, and inside it is a kind of a membrane. This is a rubber membrane. If I could draw the ball from the front, the rubber membrane would be a little bit smaller than the ball itself, and you would sort of push the ball. You would push the ball through the membrane into the box, right? Oops. Push the ball through the membrane into the box, and of course it's held there by the rubber membrane. And at this end, you might have a pneumatic cylinder that when it's time to leave the box, the pneumatic cylinder would just give it a kick out, right? So it would pop in. Now this membrane could be a sheet of rubber. This membrane could also be fashioned as a circular, bit of surgical tubing. Or I could also imagine you could use springs. You could have like a spring across here, and a spring across here, and a spring across there. Just 4 little springs that you can push the ball through the springs that stays inside, and then the little kicker would kick the ball out of the springs. So this is another idea that we talked out as a potential solution for grabbing the cargo ball. And we haven't decided which one we're going to use yet. There's probably other ideas that you've thought of as well, but once we get 4 or 5 ideas, then we say, okay, that's enough for that system. So we moved on. So that was our cargo ball idea. The last thing we wanted to talk about was the manipulator itself. So this is the standard robot here, and we thought, well, perhaps a simple elevator system. The Andy Mark elevator leapt to mind. It uses that walnut extrusion and a little tiny box inside. I think you've seen it before. It kind of looks like that, and then there's a little box inside it which goes up and it goes down. And if you use something like a chain drive, it can have a lot of force up and down. Well, that little red thing would be the carriage that goes up and down. And this dotted line, this would be our end effector, right? And if we had sort of cantilevered beams on here that were motorized, we could move them up, we could move them down. And then this thing would be able to move up and down and keep our end effector parallel with the robot. And ideally, a person might also take this mechanism and hinge it here. So this part can be tilted. Your end effector could be tilted up, it could be tilted down, or rotated. See, if we can get that tilting going on, our end effector too, we've brought in another degree of freedom. So here's 1 degree of freedom, 2 degrees of freedom, and then pivoting it there would be a 3rd degree of freedom. That would allow you to point up and shoot the ball upwards, if you choose to, or maybe pick up balls from the ground, or you can pick up balls from the regular, the low cargo hold size, and maybe we would have the front end of this robot cut out so we could actually move this thing right down into that area. So that was one of the ideas we had for the manipulator. So there was a number of concepts and ideas that we can put into our morphological chart so we can decide how we're going to actually finish this robot off. So now the next step is I'm going to look at each one of these ideas that the group of us brainstormed tonight, and I'm going to see what parts we have available, what's doable in the period of time we have. And hope then on Friday evening and Saturday, we're going to see if we can take one of these ideas and make it so. Make it so. I feel like Captain Picard. Anyways, that's Craig Maynard, again, First Senior Mentor, calling you from Mission Control. And I'm hoping this video helps you guys. Stay tuned for the last video, or videos, which will be the actual fabrication of our robot and demonstration. And if we get the robot running, if you're in Western Canada and you'd like us to come and bring the robot down to show you, just give us a call. Anyways, I'm signing off, and I'll see you next time. Have a good time building your robots, and good luck.